Ever wondered if the universe had a few surprises up its sleeve? And what if the surprising things just got worse? The Webb telescope's latest image isn't just a snapshot, it's a cosmic bombshell that's rewriting the rules of our understanding. It is like looking closely through a lens that unravels mysteries, revealing a cosmos more mysterious than we ever imagined. This image isn't just breaking boundaries, it's shattering our cosmological certainty. So are you prepared to consider everything you believed about the universe? Then welcome to a new era of cosmic revelations, where the Webb telescope takes us beyond the known and challenges our cosmic convictions. Stay tuned till the end. Studying the evolution of the universe is crucial for humans. Our desire to grasp the beginnings of the vast cosmos has driven the emergence of disciplines such as astronomy and cosmology. These fields have provided us with valuable insights into the vast expanse of space and its celestial marvels. Astronomy, one of the key avenues of exploration, delves into the observation and analysis of celestial bodies ranging from stars and galaxies to planets and beyond. It allows us to unravel the mysteries of the night sky, understanding the movements and behaviors of cosmic entities. Cosmology, on the other hand, focuses on the broader picture, the structure, origin, and eventual fate of the entire universe. By studying the fundamental principles that govern the cosmos, cosmologists aim to piece together the puzzle of how everything came into existence and how it continues to evolve. The significance of these scientific pursuits goes beyond mere curiosity. As we uncover the secrets of the universe, we gain a deeper understanding of our place in the cosmic order. The knowledge derived from astronomical and cosmological studies not only enriches our intellectual pursuits but also has practical applications, contributing to technological advancements and fostering a sense of interconnectedness with the cosmos. Scientists found that matter in the universe isn't spread out evenly. Some areas have more stuff than others. This discovery supports the widely agreed-upon Big Bang theory, which proposes that the universe originated from a singular explosive point, expanding and cooling over time. Evidence such as the cosmic microwave background, CMB, supports this theory. The CMB is the lingering light from the initial moments after the universe's birth, akin to the afterglow of the Big Bang, persisting for over 13.8 billion years. As we learn more about how the universe grows and changes, our ideas about it keep getting updated because we keep finding new things. Using fancy tools for research is a big help in figuring out the secrets of space. These tools help us see things we couldn't see before and understand how everything in the cosmos works. So with every new gadget and discovery, we get closer to understanding the universe and how it came to be. Discoveries frequently prompt the need to tweak current theories or create brand new ones. Yet it gets confusing when unexpected and inexplicable events happen suddenly in the universe. These occurrences make scientists wonder if there's a mysterious force shaping the cosmos or if our basic understanding has been flawed from the start. The unveiling of fresh insights challenges established beliefs, urging scientists to reconsider and refine their models. The scientific community struggles with the profound implications of rapid enigmatic events that defy conventional explanations. Such moments force a re-evaluation of our comprehension of the universe, raising questions about the very nature of reality. As researchers encounter the unexpected, they navigate the fine line between the known and the unknown, striving to unravel the mysteries that continue to captivate and perplex the scientific mind. And one of these noteworthy events was identified by the James Webb Telescope, the revolutionary tool in 21st century cosmology. What could be that? Let's find out the answer. But wait, just a small task before that. If you are new to the channel, don't forget to hit the subscribe button. Also, press the bell icon right next to it and stay updated with such extraordinary videos. Now back to the question. The James Webb Telescope is like an extraterrestrial space camera that takes awesome pictures of space. It helps us look really, really far away into the universe, way beyond our Earth. The telescope's main job is to watch the farthest parts of the universe and check out stars and galaxies that started right after the Big Bang. It's like a time machine but for space. So when we look at the pictures it takes, we can learn about how everything in space began a super long time ago. It's like a giant space explorer helping us discover secrets about the universe. Isn't that exciting? Now, the scientists equipped with such advanced scientific tools have explored the universe and uncovered various concepts such as dark matter, dark energy, and the expansion of the universe. These ideas provide support to the Big Bang theory. For instance, the theory of universal expansion suggests that the universe is continually getting larger. This means that galaxies and galaxy clusters are gradually moving away from each other. This expansion has supposedly been happening since the universe's birth around 13 billion years ago. Although various methods have been developed to measure or detect dark matter, none have proven entirely conclusive. The James Webb Space Telescope, however, offers a valuable tool. Through its NIRCam images, astronomers can utilize these images to calculate the amount of dark matter present in specific cosmic regions. Furthermore, gravitational lensing, another crucial aspect, contributes to this understanding. It explains how massive objects in the cosmos distort the space around them, causing light to bend as it passes through. Galaxies and galaxy clusters, in particular, induce significant warping of spacetime. By observing the effects of gravitational lensing in Webb images, scientists can map the distribution of dark matter in the vast expanse of the universe. Another finding involves planet-like objects captured in the Orion Nebula, a well-known nebula in the Milky Way resembling the sword in the Orion constellation. Previous studies of this cosmic cloud hadn't revealed hidden objects until the Webb came into play. One of the recent discoveries, however, is not only fascinating but also unsettling. According to Webb images, over 771 trillion solar systems have mysteriously vanished from our universe. This means that an immense number of stars and their associated planets have disappeared, presenting an unprecedented event. What makes this discovery even more interesting is its potential to challenge our fundamental understanding of cosmology. Scientists are now doubting the Big Bang theory because many solar systems vanishing goes against the rule that matter can't just disappear. The fundamental law states that mass cannot be created or destroyed but can undergo transformation from one form to another. The perplexing nature of this discovery has cast doubt on established principles, prompting a re-evaluation of our foundational knowledge in cosmology and astronomy. The current understanding of the universe is based on scientific laws, making it challenging for scientists to explain the disappearance of entire solar systems containing stars and planets. Some propose a theory suggesting that these vanished solar systems have undergone a transformation, turning into a different form that is imperceptible to us. This theory draws parallels with aging stars that, when unable to contain gases, explode into supernovas, scattering their mass as tiny particles across the universe. However, doubts arise within the scientific community as the sudden disappearance of stars without a noticeable supernova event seems implausible. The massive impact of trillions of stars undergoing supernovas would have reverberated throughout the universe, affecting even our Milky Way galaxy. An alternative theory considers the role of black holes in the mysterious disappearance of stars. Black holes, characterized by high gravity, can engulf anything that ventures too close, including entire stars. Yet the scale of this event raises doubts, as it would require an immense number of black holes to consume trillions of stars, making it seemingly illogical. To address this, scientist Beatrice Avroll and her team at the Northern Institute for Theoretical Physics in Sweden initiated the VASCO project. This unique endeavor involves scanning astronomical archives to identify a star that once existed in the night sky but mysteriously vanished in history, akin to the 771 trillion star systems. Discovering such a star could provide insights into why it disappeared and offer explanations for the current cosmic phenomenon. So far, no star matching the criteria has been discovered. Nevertheless, the VASCO project has attracted considerable attention from astronomers, experts, and researchers across various fields. Some specialists speculate that a star potentially crucial for the project may have vanished without being initially catalogued due to the vastness of the universe. Despite the absence of a confirmed star, Roll and the team of experts remain committed to the Vasco project. There's a possibility that a star disappeared unnoticed, challenging the conventional supernova process. Astronomer Lear Aravi proposed that certain stars might skip the typical supernova phase, transitioning directly to black holes. Aravi cited a 2019 incident where a star in its final life stage rapidly exploded and transformed into a black hole. However, the James Webb Space Telescope did not detect any black holes in place of these vanished stars. Some in the scientific community suspect a flaw or malfunction in the Webb suggests it might not be detecting the light emitted by these stars. The Webb relies on infrared cameras to capture distant objects, as the light from such objects is often redshifted to infrared. If the star's disappearance is related to light, it might not be the fault of the Webb, as NASA has not identified any issues with the telescope. It's conceivable that the light from these stars is no longer visible to the Webb due to dimming or a shift in the electromagnetic spectrum. Various theories attempt to explain the mysterious disappearances, but none singularly offers a satisfactory explanation. Consequently, some in the scientific community have considered a controversial theory, extraterrestrial activity as a potential cause for the sudden vanishing of these star systems. The debate over the existence of extraterrestrial beings has persisted for decades, with UFOs and UAPs serving as evidence for some and dismissed as myth by others. In recent times, countries like the US have put forth compelling evidence supporting the idea of extraterrestrial life. Events such as the U.S. Congress hearing in July 2023 and the Mexican Congress hearing in September 2023 have revitalized the belief in the existence of aliens. Witnesses in the U.S. Congress shared astonishing revelations about UFOs and the government's involvement in re-engineering alien technology. Additionally, during the Mexican Congress hearing, alien specimens were presented, bearing a resemblance to those depicted in 21st-century sci-fi movies. Despite these revelations, questions remain due to the absence of actual footage depicting live aliens on Earth or anywhere in the universe. And this raises questions about the credibility of the claims, leading many to doubt the existence of these beings. Even if they were real, some ponder how these aliens could cause an entire star to vanish. One plausible explanation is that these cosmic beings possess advanced technology capable of manipulating stars for their own purposes. One way they might achieve this is by utilizing stars to create Dyson spheres. A Dyson sphere is a theoretical structure that an advanced alien civilization could construct around a star, essentially forming a circular framework to harness the star's energy. In this scenario, the star becomes a colossal energy generator or battery, catering to the needs of the alien race. The idea of Dyson spheres raises intriguing possibilities about the capabilities of extraterrestrial civilizations. Imagine a civilization so advanced that it can harness the power of an entire star to sustain its technological advancements and life. This concept sparks curiosity about the potential scale of alien civilizations and the vastness of their scientific achievements. While the revelations from Congress hearings provide tantalizing glimpses into the possibility of alien existence, the lack of concrete evidence and first-hand encounters remains a significant hurdle for widespread acceptance. People continue to grapple with the challenge of reconciling these extraordinary claims with the absence of direct proof. The very nature of these revelations, reminiscent of science fiction narratives, adds an element of uncertainty in disbelief among the general populace. The discussion about aliens is ongoing, and there's a split between scientists and the public regarding whether these claims are true. In the future, new evidence or technological progress might help us understand more about aliens and how they could impact cosmic events. For now, the question of whether we're the only ones in the universe remains a captivating mystery, fascinating those curious about the idea of life beyond Earth. Dyson spheres might be possible, but the existence of aliens is uncertain. To harness 771 trillion stars simultaneously, there would need to be at least a billion civilizations. However, this theory falls short in explaining the disappearance of stars. Scientists are baffled, unable to find a suitable explanation. Adding to the mystery, the James Webb Space Telescope has uncovered a puzzling phenomenon in the distant universe. In the spiral galaxy NGC 5584, located 75 million light-years away, there are pulsating stars surrounding it that shouldn't exist. This discovery challenges our fundamental understanding of the universe. It suggests that the universe is expanding faster than our current models, conflicting with the well-known Hubble constant. The Hubble constant, named after astronomer Edwin Hubble, is a crucial factor in understanding the universe's expansion. It relates the velocity of galaxies to their distances. For instance, a Hubble constant of 50 implies the universe is expanding at a rate of 50 kilometers per second. Edwin Hubble, using the world's largest telescope, observed the universe's expansion and introduced this constant, demonstrating the linear relationship between the distance and velocity of galaxies. The recent discoveries have left scientists puzzled and questioning the very fabric of our understanding of the cosmos. Hubble was the pioneer in introducing the concept of the Hubble constant, but there exists a lack of consensus among scientists regarding its true nature. Various approaches have been attempted to unravel this mystery. One such method involves scrutinizing specific locations in space and determining their distance from us. For instance, scientists select a distant star within the Andromeda galaxy and observe the changing distance between Earth and that star over the course of a year. This observational technique enables them to discern the rate at which the universe is expanding. Another avenue of exploration entails studying a phenomenon known as the cosmic microwave background, CMB. The CMB is not merely a backdrop of light, it also possesses a measurable temperature. As the universe undergoes expansion, the temperature of the CMB decreases. Scientists have observed a reduction of approximately 2 degrees over a span of 10 years. Recognizing the correlation between the cooling of the CMB and the expansion of the universe, scientists employ this data to estimate the elusive Hubble constant. But there's a problem, these two methods never agree on the Hubble constant. Scientists call this disagreement the Hubble tension. They don't know why the methods give different answers. Now there's a new twist. The James Webb Space Telescope is showing that maybe both methods were wrong from the beginning. It suggests the universe is expanding much faster than what we thought. In simple terms, Hubble started this idea, but scientists are arguing about how fast the universe is growing. They use 2 ways to measure it, but these ways don't agree. And now a new space telescope is hinting that they might both be off. It's a bit of a puzzle in the science world. Our understanding of the universe gets a bit confusing when we realize that scientists keep changing the way they think about it based on new information. At first, these changes seemed necessary, but now they seem more like quick fixes for problems in the Big Bang theory. The James Webb Space Telescope has recently shown us things that make us question the way we usually think about the cosmos. It's important to know that the way we currently understand the universe goes back to a big discovery by Edwin Hubble in 1929. Hubble saw that galaxies far away from Earth seem to be moving away faster, suggesting that our universe is expanding in all directions. Ideas like dark matter and dark energy were developed based on Hubble's findings, and there have been adjustments along the way, like adding the concept of cosmic inflation. The cosmic inflation theory suggests a rapid expansion in the first fraction of a second after the Big Bang, ensuring a smooth and homogeneous initial expansion. However, loopholes persisted, giving rise to the multiverse theory, proposing an infinite number of universes. Despite these efforts to clarify our universe's evolution, the recent Webb revelation challenges the validity of the Big Bang theory and previous adjustments. Many scientists think it's time to change how we understand the universe. They believe we should stop using the old way of thinking called the Standard Model and start fresh. When the Standard Model was created, we didn't have powerful tools like the James Webb Telescope. This makes some scientists think we should let go of old ideas and make a completely new model. Also, astronomers and cosmologists agree that we need a new way of thinking, but getting everyone to agree on it is hard. It's a challenge to make sure the whole scientific community is on the same page. But we can't just ignore the basic rules of physics as we search for new answers. Even if the Big Bang Theory turns out to be wrong, scientists have few choices. They have to stick to it until a better, more advanced, and widely accepted idea comes along. And that's all for today. Thanks for tuning in. Until next time, take care.